What's going on YouTube? This is Ipsec. I'm doing RainyDay from HackTheBox. And I really like this box because it shows the importance of doing a beyond root to actually understand what's going on. If you don't do that, some of the steps may have seemed really silly and you come out with a negative opinion of the box. There's two things in particular. The first one is the type confusion vulnerability and the API, how you pull users. If you give it 1, you get an access denied essentially. If you give it 1.0, it outputs the information. And what's happening here is if you give the Python function int a string that's just 1, it returns okay, it returns 1. If you give that int function a float that's also a string, it crashes. So that's really cool and unintended behavior, and in this case, it returns data. The second piece is cracking. Bcrypt has a maximum password length that a lot of people don't know, and you can bypass that with emojis and eventually leak a salt that is prepending to a password. So if you don't do that, you just think, oh, you had to choose a magic word list and rule and like blindly guess it. But there's a way to enumerate it, which is pretty cool. So let's just jump in. As always, we're going to start off with an nmap. So -sc for default scripts, sv, enumerate versions, oa, output all formats, put in the nmap directory and call it RainyDay. Then the IP address of 10.10.11.184. This can take some time to run, so I've already ran it. Looking at the results, we have just 2 ports open. The first one being SSH on port 22, and its banner tells us it's an Ubuntu server. Now, the weird thing is we see just Ubuntu 3. I'm used to seeing like OpenSSH 8.9p1 to Ubuntu 0.2. Just seeing the Ubuntu 3 was a little bit weird. It turns out this is likely going to be Ubuntu Jammy. If you went to packages ubuntu.com and looked at OpenSSH server, you can see what everything is. Like Ubuntu Bionic is 7.6p1 for Ubuntu 0.5 likely. But if we go all the way down here and look at this one, we just have 1.89p1-3. It doesn't have anything else. So likely going to be Ubuntu Jammy, which is 2204. And then we have HTTP on port 80. It's running Nginx 1.18.0, also on Ubuntu. And then the last odd thing I'm noticing about this nmap, we know the box is called RainyDay, but it's redirecting us to rainycloud.htb, which is just a little bit odd. However, let's just add this into a host file. So sudo vi etc host, and then 10.10.11.184 rainycloud.htb. Save that, and then let's go back to Firefox and browse over to the web server. So let's go to 10.10.11.184, and we get the welcome to Rainy Cloud. It is a simple hosting service, and that's all you need. And it looks like there's one container online. It's secrets. The username is Jack. And there's 2 containers currently available. That's Alpine-Python and Alpine. If I click on My Containers, it brings us to a login prompt. We can try logging in with like admin. We get login incorrect. A user was Jack, so I'm going to do Jack and then just a famous or 1 = 1 SQL injection payload to try that, and nothing like that really works. We could go over to sign up. I'm going to do ipsec, the password of password, log in, and apparently I have a typo. So let's do password, sign up, and registration is currently closed. So I'm going to go back to the homepage, see if there's anything I really missed. Doesn't look like there is. There is a login, but we saw that. Interesting enough, if we click login, it just brings us back to the page. So the first thing I would do is try to figure out what built this web page. So I'm going to press Control-U to look at the page source and see if I see anything that gives it away based upon this. I see Bootstrap, which is a common thing for just small websites. Nothing really sticks out to me in the HTML source. My favorite way to fingerprint like the framework of what's being used is just testing some files. So like index.php to see if it's a PHP app. We don't get anything. If we do index, we don't get anything. Let's try index.html, and we don't get anything. So I'm thinking it's probably going to be some type of Python framework just based upon this behavior. And go to a page that doesn't exist, and we get this not found message. And if we Google this, if I just Google this phrase, you wouldn't think this is unique to anything in particular, but looking at it, we see tons and tons of references to Flask with this page, like Flask, 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 flask. This one's in the Flask subreddit. We have a VMware KB article. Maybe this VMware app is using Flask. Like, I don't see Django. I don't see anything Ruby. Here's another one that says Flask. So I'm going to guess this generic 404 message that people have probably seen 100 times is unique to Flask itself. So all I know is there's a Flask web server. Doesn't really help me right off the bat, but I think of some like SSTI vulnerabilities I may try later if I get to inputs, maybe Jinja 2 templating language, which is common with Flask. I'm just thinking like of Flask things to do. And while I think my favorite thing to do is start some recon in the background, so I'm going to do go buster, dir for directory mode, -u URL, put the URL word list, and then opt sec list, discovery, web content, raft, small words.txt. And I'm not going to do any extension because I don't know what extensions really work well with Flask. And then we can do output of go buster.out. And then the next thing we can do, we see there is /new, which redirects to /login, but there is a /API. So I'm going to go to /API, and it looks like there is a unfinished API that we can access some things. So I'm going to go to like /API/list. So Rainy Cloud API list. There's a colon there, so let's get rid of that. And this just lists the containers. It's pretty much what we saw on the homepage. So I'm going to try the health check. So if I go to /API/healthcheck, it just says true. So maybe this is just testing if some service is online, and it would say false if it isn't. Then there is this /API/user/ID. So let's test this out. I'm going to do API user. Let's do ID 1. And we see we're not allowed to view that user info. So I'm going to do 9001, and we get nothing. So this tells us that user 1 exists. We can probably do user 2. We can't see that. I bet if we are logged in and try to view ourselves, it would print out our information. However, we can't do that. There is one weird vulnerability where we can just make this one a float and put a decimal. And it actually bypasses it. So what's going on here is Python is treating this as a string. And I'm guessing the developer put something as like an int to try to make this conversion to be an integer, right? So if we do int 1.0, it's like this. But it's retrieving it from the database. And whenever it retrieves something from the database, it's a string. And you may think this says 1.0 or 1. But it actually fails. So that is why we're able to bypass the check. And hello, this is me from the future. I'm going to try something new in editing clips where I normally put at the end of the video, but just put it in the middle because you're probably confused by that whole logic I just said there. So let's look at the Rainy Cloud web code. So if we go var www rainycloud app.py, we see the Python script. I'm going to look for the route. So I'm just going to search this for route. We see /new API list and API user ID. So here we can see the actual code that we just exploited. And we see at first it's going to do a query on the database, filtering by user ID, and it gets the response. And here we are checking the response. And if the user ID does not equal the session, which is the active user that's logged in, display this error message, right? And it wants to make sure both of these are integers, so it's doing an int UID, and because it's in this try, that's where it's failing. The UID is the parameter we pass in here. So it comes here, we see this U, it gets the response, and this is going to be the database row. Pass in this integer of a string 1.0 and it crashes, right? If I just do Python 3, we can show again. Let's just do x is equal to 1.0 as a string. If we do int x like this, it crashes because you can't do an integer on a string. It's not smart enough to do that type conversion. If x instead was 1.0, well, before doing that, I think we can do like type of x or type x. Yeah, it's a string. So if we do y is equal to 1.0, do a type of y, we can see it gets defined as a float, and then we do int y, and since it's already a number, it translates that down to 1. So hopefully this cleared up things. Let's get back into the video. So now that I can get password hashes from users, I want to find out all the users in this database. Now I could just go 1, 2, 3 like we did before and see this error message, but if there's more than 3 users, that's very time consuming. So what I'm going to do is use a tool called fuff, and we're just going to do fuff-u. Actually, I'm going to send this over to burp because I always like using the fuff request mode. Similar to how I do SQL map. I like keeping my workflow pretty much the same between tools when they support it. So I'm going to copy this request to a file, put it in HTTP. This is RainyDay. And then I'm going to do user search.request. And now that we save that, we can do v user search.request. And I'm going to fuff right here, fuzz right here. So we put fuzz in all capital. And we could also add a .0. We'll do that after this real quick. So we can do fuff-h, and we want -request, and the request name, which was user search, and then request proto HTTP, and then we want to specify a word list. And because we're just doing numbers, we could just make our own file, but OXDF taught me a cool trick with this bash operator. So if we do this fancy redirector of the less than parentheses, we can do sequence 0 to 100, and it will treat this piece, this piece as a file, right? So we just gave it a word list of 0 to 100. Normally, I would break this off into 2 steps, but we can do this and just do 1. And when we run it through, we can see what the size is. So I'm going to filter size of 3. So it's going to hide everything that's the size of 3 here. And we see there's only 3 users. Now, if we also wanted to do the exploit, because we're using the request, it becomes super easy. We could just do fuzz.0, and this is probably going to change what our filter is. No, it didn't. Filter size 3, and again, it sees it there. The difference being the unfiltered size is 101 because it's displaying a lot more information. Up here, before that .0, it was a size of 50 because all it was doing is displaying that error message. So that is how I would use fuff with this. And now we can just curl to download all the users. So I'm going to curl rainycloud.htb /that. Let's see. Let's do 2.0. I'm going to pipe it over to JQ. And then we're going to get the password like that. Awesome. And if we wanted to do some real magic, we can put both the password and the username on the same line, so it makes it a really clean word list. So I'm going to put this in quotes. I'm going to do period and then a pipe, and then each field we want within a double quotes, and we want the field escaped parentheses. It's really weird syntax, right? So that's going to put user, and then I'm going to do a colon, and we do the same thing with password like this. And even though this JQ syntax doesn't make sense, it does what we want. It was username, actually, not user. There we go. And I'm going to do curl -q. Maybe it's a -s to hide the thing right here. So now we have that. I think I can do like, is it -r for raw? There we go. So now we don't have the quote either. So we have a really good query here. I'm going to wrap this in a for loop. So for I in sequence 1, 3, do, and then we'll put a I here like this, and then say done, and see what this does. And we get all 3 users. So we can pipe this over to passwords.txt. And now when I cat this, I just have a clean file of all the hashes. So let's copy these over to the Kraken and try cracking any of these passwords. So start off with SCP. We'll SCP passwords.txt to the Kraken, and then we SSH in there. I don't know why I did CD there. So SSH, and then we can SCP passwords.txt to where I generally store it, and it's generally in hashcat/hashes, and I'm going to call it RainyDay.txt, just so, oh, let's do MV to move it. There we go. So now we can go into Hashcat and try cracking it. So /hashcat, and then we give it the hashes. So hashes RainyDay.txt, and then the word list, I'll just use rocku.txt. And it's going to start in auto detect mode, and it can't find anything that matches this structure because we have it username : the password. So I'm going to add -- I think it's just user in Hashcat, and this will do it in the correct way. It still fails because there's 4 different hash modes that match the structure. And I'm going to guess this is not form CMS e-commerce. It's just a bcrypt thing. So I'm going to specify -m 3200, and we'll see if we get any results. So it's going to start initializing all the devices, and we'll see how quickly this thing does crack. It is bcrypt, so it can take a while. And when you get to these stronger hashes, definitely make sure you don't do it on a VM, because your VM is going to go infinitely slower than your host computer. I'm just doing it on this Kraken or a separate computer because I don't want to record and crack at the same time. So yeah, if we do S, we can see the speed. It's only doing like 459 hashes a second per like video card, which is incredibly slow. I'm used to seeing like thousands upon thousands of hashes per second when it's like NTLM. So bcrypt, much stronger. And we do get one thing that's cracked right away, and it's rubberducky. We could go back to Hashcat or go back to the word list and find which user had that hash. But the reason why I like storing the username with my password hashes using the -- user flag is because we can just get rid of this. I think we still have to do mode, but we can have a -- show option, and we see Hashcat is telling us Gary has the password rubberducky. So now we can log into the application, or at least try logging in. So renycloud.htb, it's going through Burp Suite. Let's just turn that off. We can log in. Actually, we have to click on My Containers to get to login form. Gary, password of rubberducky, and sign in. So now we have the same exact page. We're definitely logged in because it says log out now. If I click on My Containers, I can do new container, and I have 2 options, Alpine-Python and Python. I'm just going to do ID in this container, or actually, this is a container name. So I'm going to call this ipsec Python and create. And I'm also going to create another one and just Alpine. And I'll call this ipsec with nothing. So now, if I click on My Containers, actually, ipsec Python did not work. Maybe it doesn't like a dash in the container name. I'll call this Python. Yeah, I'll just call it Python. See how that works. Okay, so we have 2 containers. I'm going to execute a command, and we can execute ID. And then it does this open with, and we can see my user ID is leet and the group is leet. Let's try doing it on the ipsec container. So if I just do ID here, we see the same thing, leet. So I don't know what's different between these containers. I'm going to guess one has Python, which one doesn't. So if I do the ipsec container, that was the no Python, just running which Python 3, we get nothing. And if I do it on the Alpine-Python container, I'm assuming it has Python 3, right? So we see a path here, user bin Python 3. The other thing I noticed weird is this port thing. We have port 40,003, 40,002. So I'm going to guess maybe the container we don't see. That's weird. I'm guessing mine with a dash broke. Because I see this ipsec Alpine. Yeah. So the dash definitely broke something. I don't know exactly how it broke, but we see the container has a duplicate name. I don't think that should be possible. This is definitely the first one with Alpine-Python. We have Alpine-latest. The thing that's confusing me is the user is now the port in that one container. Not sure exactly how that happened, but the ports for these 40,002, 40,003. So I'm going to guess the secrets container is mapped to just 40,000. So I'm going to go back here and let's just do nc-zv 10.10.11.184, and we'll do port 40,000, and we get connection refused. Do 40,001, all these ports, connection refused. I'm going to go into my containers, and let's see if which is enabled. So if I do which nc, we do have that. So I can probably do nc lvnp 40,002. I think that's 40,000. Let's just run this command and see what happens. So now it's running. It says it's in the background. So if I do this nczv, it says it's connected, and netcat probably closed after that, and it's back to closed. So we know there's some type of NAT into these containers, but the secret container isn't running anything. And I'm guessing we want to get into secret. So my first step is to get a reverse shell. And just like the Python, I'm going to do which bash to see if this bash exists on any of these containers, and it doesn't look like it does. So which bash here, and nothing. So the next step is let's just do a Python reverse shell. So I'm going to search for reverse shell Python and probably go to payload all the things because it's a really good GitHub repo and has a lot of things I just know work. So I'm going to go to Python, and we can copy this payload. I'm going to go to my terminal, and let's just edit it because we want to change the IP address. So I'm going to do 10.10.14.8, and I'm going to go on port 9001. So let's actually, before we copy it, put Python 3 here. And we can copy this entire string. And I'm also noticing the pty.spawns bin sh, which is good because bin bash does not exist. So make sure that's copied. nc lvnp 9001. Go back to the page. Enter in this command. Go back, and we have a shell. I'm going to do Python 3-c import pty.spawn. Bin sh, so we get a proper pty. We also have to do stty raw minus echo foreground. And there we go. So now we're on this box. If I run ID again, I'm ID 1000, which is odd because the web page, when we do execute command, we're ID 1337. So there's something different between this execute command and execute command background. And what we're about to show is the unintended route. There is an intended route. There's supposed to be 1337 on background as well, I believe. But I'll go into the intended route at the end of the video. So if I do a ps-ef just to see what's on this container, there's going to be one thing that really sticks out. So looking through, and I see it now, there is this super long running sleep command on the container. And it started by ID 1000. And because it's ID 1000, we can go into its proc directory because that's our user. So we can see information about the process of ourself. It was 1194. 1000 was our UID. So I do lsla. If we look at cmd line, we get the sleep command. If I look at environ, we can see it is home jack. And let's see, is there anything else that is too interesting here? The home directory is home jack. And if I go to /home, there is nothing in /home. And if I look at etc passwd of this container, let's see if jack even exists. We can grab 1000. Jack doesn't. So this process is running from the parent. If I do lsla with this and look at CWD, we see home jack is mounted here. And because this is a shared space, from the container, if I do LSLA on the CWD of this process, I can get into the home directory that's on the user. And that's what you're supposed to do from the secret container. I think the secret container just runs as UID 1000 on the execute command and everything. So, yeah, but let's just skip that step. We see there is a user.txt. If I go into .ssh, there is a IDRSA. So let's cat this IDRSA file. So we can cat it, and we get a SSH private key. Let's copy it, and then go back to our host, and jack.key, I guess I'll call this, paste it in, chmod 600, jack.key, sh-i, jack at 10.10.11.184, and accept the SSH fingerprint, and we get logged into RainyDay. The first thing I generally do when I have a user, especially if I know his password, is look at the sudo entries. And here we can see I can run user bin save Python as jack ADM with any arguments, which seems really silly. Like, this should be easy to exploit, right? I don't know exactly what save Python is, so I'm going to do a file against it. If I look at it, we see it's a regular file, but I have no read permissions to this file. So as jack, I can't really do anything. The only reason I can execute it is because we can su to the jack ADM user. Additionally, we only have read permission on this binary, not write permission. So let's do a sudo-u jack ADM, and then user bin safe _ Python. And I'm going to just try like a module real quick to see if this works. Permission denied -m. So it's looking like save Python wants to open a file, and I can't use any like modules or flags like this. So I'm going to go to dev shm. I'm going to create test.py, and then we're going to import os, and then os.system and bin sh like this. And when I try to execute it, we'll see what happens. So dev shm test.py, it gets this import command not found. We could try other things. So maybe we can just read a file, right? So instead of import os, I'm going to do print and then open etc passwd dot read like that. If we do python 3 test.py, we read test.py just fine. So the first thing I want to do is look at jack ADM's SSH key to see if he has one set. So I'm going to put in the path and then .ssh and ID _ RSA. Try to read this, and no such file or directory. We could try reading other files like .bash history, but we don't really get anywhere. And there is no .ssh directory in his home directory, so we can't write the file. There's not a good way to test for it, and we can't create a directory without importing the OS module. So we're kind of at a dead end right here. We could try arguments like -i to drop into a PDB instance, but every single thing that we try to pass to save Python, it wants to be a file. If we do ps-ef and grep for jack _ ADM, there's nothing there, right? If I cat etc passwd, I definitely see that user. So don't know what we can do. We can't really write a cron to that user because I don't think we can just like open bool cron tabs jack because we get permission denied. The reason why you can create crons is because the cron binary, I believe, is set UID or something, and it has permissions to write to that directory as you, or all the files are root. I don't know exactly what that works. I just know as a regular user, we can't just drop a file there and get it executing as code. We need to be that user have a proper PTY. So like if I do, let's see, cron-e, or was it cron tab -e nano, if I save this file. Now I look at the same verse bool cron jack. Access denied because we just don't have access. ls-la, which cron tab. We can see it is set UID. So that's why we can create those files as this user. So I'm drawing a real blank at exactly how to exploit this. And at the time the box was released, there was a lot of buzz around some Python vulnerabilities. So people may just know just because it was a month or two ago on Twitter, but now the box is retired. It's been much longer. But once I've exhausted all the abilities to execute out of a sandbox, which is what I'm calling safe Python, I would Google like trying to exploit the Python binary itself, right? So I'm going to Google Python use after free to see if there's been any like vulnerabilities in the Python application itself. Use after free is one of the most common bug classes for binary. And this very first post, pwn.win, goes over it. So if we read this whole thing, we'd understand it. I actually don't really understand this exploit, but they do give exploit code at the bottom that we can just throw in. So if we look at exploit.py, we can do the script kiddie thing, give the exploit a glance over, make sure it's probably not doing anything dangerous. If it is, well, at least this is HackTheBox in a temporary machine, not some type of production, right? So I'm going to call this just exploit.py. We'll paste in this exploit. I forgot to do set paste. So should always do set paste before you copy because you may get things like I just did. So set a mode to paste it in. And we can see at the very bottom of this, it is setting RIP to bin sh to execute it. So let's now exploit or call this exploit. So where is our Python? And we're just going to do dev shm exploit.py, do an ID here, and now we are Jack admin. I'm going to go into my home directory. Let's create a SSH directory, and we can create a file. So SSH keygen -f. We can just hit enter. We could do that TTY trick and get a proper TTY, but I'd just rather do it this way. So move id rsa.pub to authorized keys. What? Oh. Move id rsa.pub authorized keys. And then we can cat id rsa, and we'll copy this over to our box. So highlight everything. And then v jack adm.key. That's the wrong paste. There we go. sh-i, and then jack adm at 10.10.11.184. And we have to chmod 600 jack adm.key. Log in. And now we're a shell on this box as jack adm. Let's check the sudo rules for this user, and we can see we can execute something as a root, and it's opt hash system hash password.py. So if I try to less this file or do an ls, we can't even like view anything about this. So let's just try executing. So I'm going to do sudo, execute it, and it wants us to enter a password. So I'm going to enter please subscribe, and it gives us a hash. So let's just try cracking this hash with Hashcat to see what happens. So I'm going to go back into the Kraken, so SSH Kraken, and let us go into Hashcat. And then I'm going to do a file called, we'll move that to hash, and then we'll create password and write please subscribe. So in theory, if this just did a standard bcrypt, and we know it's bcrypt because it's got like this $2b05, right? So we'll do dash mode 3200 just like before. We'll pass in the hash and the password. And trying to crack this, it doesn't actually crack. So we'll just give it some time. We could also use Python to check this. I know OpenSSL probably can check it as well. There's a lot of ways to check a bcrypt password, but I just wanted to show Hashcat because that's what we've been using so far in this video, and we get recovered 0 out of 1. So what I'm thinking here is this script, this hashpassword.py, appends a salt to the password. And when it does so, it's making this password unique. So we don't know what it did to please subscribe. So it could have done like please subscribe and put a bunch of junk. Could also prepend it and put junk there. What we want to do is try to figure out exactly what's happening. And we can do this because bcrypt has a maximum length. So if we do bcrypt maximum length, go to Google, we can see generally bcrypt has a maximum length of 72 bytes. And what this means is if we go beyond 72 bytes, it's going to start truncating things and removing it, right? So if we had enough junk here with please subscribe, or it truncated whatever the length right here is, then anything that goes after it will not take effect. And this is really interesting because I know a lot of websites like limit the password length. And before doing this box, when I saw sites limiting a password length to like 72 characters, I was like, why do that? Where's that limit come from? It's because of bcrypt itself. So you can kind of understand how the hashing works on the back end of the site just based upon how long they allow the password to be sometimes. So let's try exploiting this, right? So I'm going to execute this. We're going to put a ton of A's here. So let's copy this and just fill this up, right? And it's saying the input length must be less than 30 and greater than 0. So we can't fill up to get to the 72 byte limit with just ASCII characters. And that's where Unicode is actually going to come in. So if I just Google, let's do, we'll do the Unicode for bomb because we kind of fill the buffer, right? So let's do this, and I'm going to copy this character, and it copies into my terminal just fine. So I'm going to open up a Python panel here, and if I do like X, and then we length this, we can see the length of a character is 1, but the length of this Unicode character, we probably have to do .encode, right? Is 4. And we can change this back to X. So we can see the length of these Unicode characters is bigger. And if the Python script is just checking the character count and treats a Unicode as 1 character, when we input 20 of these bomb emojis, it's going to expand into 80 bytes and it won't crack, right? So let's test our theory. I'm going to print this times 20, and we'll grab all of these, go in here, enter the password, and we get this hash. I'm also going to do 20 minus 1. So let's go back into hash. We'll put this one, and then I'm going to go up here, copy it, run it again, put it in, minus 1. I don't know what just happened there. Let's try it again. There we go. I'm guessing my backspace did something weird to that Unicode character. Not sure, but that was definitely unique. I think that's okay. That is 2 lines. We can save it. So we have the hash of 2 of those bombs. So I'm going to go VPW. We'll put this in. Let's go back here. Copy 20 of them. Paste. Minus 1. I'll use the X actually. So we'll put these and then remove this. And I'm using X in Vim just because the backspace behaved oddly last time. So now we have 20, 19, 18, 17, 16, 15, and 14. So that's going to be our word list. Actually, let's remove 20. And when we crack, both of these should crack to the same thing. We'll say this was 20 and this was 19. And that's 20 bombs, 19 bombs. So now when I do hashcat-m 3200, we give it the hash first, the password, and we also want to specify user. So let's try cracking it, and it should crack both of these pretty quickly once it initializes this backend. But the thing we're going to see is it cracks them to the same password because that is the maximum buffer length in bcrypt itself. So there we go, recovered 2 out of 2. So let's get rid of pw and do show. And we can see we inputted a different number of bombs, but it cracked to be the same thing. So now we have confirmed we can overfill the bcrypt buffer and start extracting things. So I'm going to clear these screens. And what we want to do is figure out how many it was. So let's count this. So 1, 2, 3, 4. Then 1, 2, 3, 4. So that's 8. 1, 2, 3, 4. That's 12. 1, 2, 3, 4. That would be 16, 17, and 18. So what we want to do is put 17 of these bombs on a line. And then we're going to give it 3 bytes of junk. So whatever the actual script appends to this, it'll append, let's say it does please subscribe. Because we know that it's going to truncate at this byte, we'll be able to crack one character at a time and figure out exactly what this is. So I'm going to copy this, and we're going to paste it in and get the new hash. So let's v, this is hash. Okay. And we'll go pw, and I'm going to copy this. And what I'm going to use is a Hashcat rule to append one character to this. So if we Google Hashcat rule file and see rule-based attacks, I think it gives us a pretty nice table here that says what we can do. And if we look, we can append a character. So this $x is going to append X to the end of the password. So this example, $1, $2 appends 1, 2. So I'm going to create a quick rule file that will append every character. So we can do for I in, actually first, I am in Python here, so we can import string. And if I just print string.printable, we see a bunch of printable things. The actual, I think, last 6 characters are not printable. Let's see. This way, yeah. The last 6 characters are weird. So normally when I do string printable, I append it like that. I'll show it both ways so you can see better because this example didn't exactly work. So let's do for I in string printable. Yep. And then we can print. I'm going to do $, and then I. So that's going to append every character, right? And the last 6, it's not really doing so hot. So if we just did -6 like this, print, it gets it a bit cleaner. Not a big deal at all, but let's copy this. So this is going to be every printable character. And we can go to Hashcat, and I can say append char.rule. And there may be a Hashcat rule that does this already, but it's pretty cool to show it, I guess. So now I can go back to Hashcat mode 3200. We give it the hash, the password, and then the rule file, and try to crack it. And it shouldn't take too long, and we'll get the first character. And then we just kind of repeat it constantly until we get all the characters. But I'm going to switch away from Hashcat, and we're going to just go into a Python script to do it because that will be much quicker. So we can see recovered 1 out of 1. If I go up above this, we can see we have all 17 bombs, the 3 A's, and then H. So the first character of whatever it's appending is H. So let's go into dev shm, and I'm going to v crack.py. The first thing we need to do is just import OS because we're going to be executing system commands. And I'm just going to test this out by doing an os.system command in order to make sure we can get the data we want, right? So we need to do sudo, and I should have saved exactly what we run. So we run this. If I do ABC here, it looks like it still wants us to enter the password. So we have to echo something into sudo. If I just do echo A like this, then it works just fine. So that's how we're going to do it in the Python script. I should copy this and then go into crack, paste, and just make sure we can do this from within Python. Looks like we can. And we just want to grab the password hash. So I'm going to split upon a semicolon space. So let's do x is equal. And os.system, we actually don't get anything. So if I do that, it prints 0 because os.system runs and goes to standard out. I need to do os.popen. And now, I need to .read. There we go. So let us, what was I going to say? Oh, we need a split. So x.split, semicolon like this. And we're going to grab the second match. When I run it, I did this like that. There we go. And we get the hash, and it's got a trailing line break. So if I just do a split after this, so we print this dot split, or not split, strip. There we go. That looks better. So I can say pw hash is equal to this. So now what we have to do is loop through everything. So let's do a while true. And then we indent both of these. And before this, we need to define the secret. And this is going to be what it is appending. So we're to start out with nothing because technically we don't know it. And now we have to build that 71 character buffer right now that we decrement one time every time we get a password. So I'm going to do the length is equal to 71 minus the length of secret. Because the very first one, we want to send it 71 bytes of data because the max is 72. And then once we get the first character, we want to send it 70. So when secret is 1 character long, it decrements by 1 that way. So the next thing we have to do is figure out how many A's to put in after all the bombs. So if we do 71 modulo 4, that's going to be 3, then 70 like this. So that's what we're going to do. I'm going to call this the remainder because that's what I think of when I do modulo and like long division, it's the remainder. So length, then 4 like that. The next piece we want to do is I'll call it the junk, I guess, because when we do like binary exploitation, that's what we generally call it. And that'll be the bomb emoji times the length divided by 4, because each one of these is 4 characters long. So let's do if I cat pw, I can grab one of these and put that in. Now, there's two things we can do about this because this code is going to fail right away. If I do 71 divided by 4, it's 17.75. Generally, I would do int like this. So we can do int, but after talking with OXDF, I did learn a cool Python trick is if we do 2 slashes, it will automatically do that. So you can do it either way. I don't know if that's a standard programming thing like that. So to me, the int looks more standard, but I guess the Pythonic way would be 2 slashes and you kill that thing. So now that we got this, after the junk, we will need to add the A's. So I can do junk plus equals to append, and we'll do A times the remainder. So now we should have a password. So I can do echo and then junk. Maybe I should call that buffer or something. But the first time we'll send it 17 bombs and 3 A's and get the H out of it. At least that is the hope, right? So now we can do a for I in string.printable. And then we can get rid of the last 6 things. And we'll need to import string. And we also, while we're importing, need to import bcrypt. So in this loop, what we're going to do is say the password is equal to junk and the secret and then I, because that's going to be each character. And then we can say if bcrypt.check pw password and pw hash. So this is going to be the bcrypt function to check if this is valid. And if it is valid, we're going to append secret with that character and then print secret and break. So when we run this, let's see what happens. Unmatched, so line 12. pw hash. I was printing before and I didn't get rid of that trailing. And the bcrypt function looks like it wants encoded things. So we can probably do pw.encode and pwhash.encode probably. When we run this, we get heavy rain, and then it stops. Typically, when I do these cracking scripts, I like to use a little bit of flair, I guess. So we can do print, and then if we do a return character to flush standard out, then secret like this, and end is equal to 2 quotes. And we can do something very similar above it. We can do secret I like this. And when we run it, we get an unexpected indent. There we go. And it just prints it out in one line. And then we get to this end because there's nothing left. It's just looping infinitely. We could have killed that, but oh well. So we know it is going to be heavy rain is what it appends to it. So we can take this knowledge and go back to our very first crack probably. So if I cat, what is it? Hashes, this is RainyDay.txt. We have a root password hash here that we never cracked. We only cracked Gary's. So we know this bcrypt thing is appending heavy rain. So what if we took a word list in Hashcat, appended heavy rain to it? Do we now suddenly crack root? Well, that's what we're going to test. So let's do v, I'll call this append string.rule, and we're going to put heavy rain here. And then if we looked at this, how they append multiple characters, you just put a dollar between the characters, And I actually wouldn't do it this way. We'll do it two ways, but Hashcat has a combinator mode. And that's generally how I would do this, because typically you wouldn't create a rule file just appending one thing. You'd want to do two word list, and this gets to be a bit of a pain. So it's always nice to have options. So I'll show you both. So let's do hashcat.bin. Trying to think. Oh, we called it, yeah. So we can do this, mode 3200 for bcrypt. Then we say hashes RainyDay.text. And then we want to give it a word list. So opt word list rocku.text. And then -r for a rule file. And we're going to append string.rule. And now when we run this, we get an error because we have to specify --user. And I guess --user and username both do the same thing. I always think, is it one or the other? And then it always works. So I think I'm just right. But I think that's a bet you can't lose, because the help was saying username and it's working with user just fine. So looking at this, we have this long string that did crack. So if I copy this, let's just do a --show for good measure. We see that is root's password. So if I go back to my shell, do a su dash, paste this in, we get root at RainyDay. Now let's look at the combinator attack real quick, because again, that's probably my first bet how it would go. So if we do hashcat attack mode and Google this, let's see, combination, there we go. We get the combinator attack. And what I like about this that we couldn't do in the last one is you can actually specify rules on the left side and the right side. So if you wanted to get a word list, put something in between the two dictionaries, you could easily do that, because you have the left rule, which is the left dictionary, and then you have the right rule. So if I appended a dash, let's see. So here we do the left rule, append a dash, the right rule, append an exclamation point, and we get yellow char like that, right? With a dash in this. So it becomes really flexible. To make this work, though, we will have to go into a pot file and remove a single character. And I don't want to open my pot file on the stream, so I'm going to pause the video and make sure my pot file is clean. Actually, I don't have to do that. I can just move hashcat.pot file and .back.vid, I guess. If I tail-1 this file, all it contains is the things you've cracked, right? I've cracked 2 things today, or I've cracked 3 things. So this is how it knows what you've done. And if I didn't do that, it would never show me cracking heavy rain, because it thinks it already did. So I'm going to call this v special dict.text and just put this word in. So now what we can do is /hashcat.bin dash, I think A1. Let's see. A1 for attack mode 1 dash mode 3200. And then we can say the left dictionary is going to be opt word list rocku.text. And, oh, we need the hash. So hashes RainyDay.text. And then the right word list is going to be special dict.text. So when we run this, hopefully it all works. You have to do the user again. This time I'm doing username, and it does work with both of them. So the longest time is probably going to be initializing this back end. But once it's done, hopefully it cracks just fine. And I'm going to guess, yep, right there we have it. So that's it, cracking with the combination file. So we skipped quite a bit when we did the user in this box, because you weren't intended to be able to get into that home directory from a container you start. You're supposed to have to sneak your way into Jack's account on the actual website of back here. So let's show that entire process. And we diverted from that at the very beginning of this box during the most important part of our attack methodology, which is recon. So we discovered the subdomain, or the actual domain, rainycloud.htb. We never did a subdomain brute force. If we had done that, we would have discovered something very interesting. So if we do fuf-u http 10.10.11.184, I think that's the IP address, and then we specify a host header, so host fuzz.rainycloud.htb. I think I misspoke earlier. I said rainyday.htb. The subdomain always throws me off. We want to do a word list, so opt, sec list, discovery, DNS, and then let's do subdomains, top million. We'll do 5,000.txt. So if we just hit enter, we can, let's see, match the code 200 to only show things that respond with HTTP 200 and see if we get anything. It doesn't look like we will. So what I'm going to do instead is filter something. So we didn't get anything. Let's look again. I'm going to filter size of 229 just to see what happens here. And we can see there is a 403 status code, which is dev. So I'm going to edit my host file and say dev.rainycloud.htb. And let's try accessing dev. So dev rainycloud HTB. We get invalid IP address, access denied. So from this, it's pretty obvious we should proxy through it. And since we can start a container, we have that ability. So I'm going to go back to this netcat. This is when I did the shell on this. It was a simple Python reverse shell. And what I'm going to do is, let's just go in temp. I should be able to write there. I'm going to touch T. Yes, I can. So let's set up chisel. I'm going to make dir dub. I'm going to go in there and I'm going to copy chisel, and I have it in my op directory. So I'm just going to copy it like this. We'll chmod plus X on chisel. And I also want to go in dub, and we can start a web server. Let's see. I need to -m HTTP server. So now we can wget 10.10.11.184 port 8000 chisel. That's this box. 10.10.14.8 is my IP address to download chisel. Okay. So now I can execute chisel. So we can do /chisel, put this in server mode, reverse, SOX5, and port is going to be 8001. And we can do chisel, client, connect to me. So 10.10.14.8, port 8001. I'm going to say reverse, SOX, I want to say SOX5, permission denied, chmod plus X chisel. Missing port. Okay, our SOX. So it's weird. The arguments on the server, it wants SOX5. On the client, it wants just SOX. And now we have a SOX proxy listening on 127.0.0.1.10.80 that's going to proxy through this. So I'm going to go back into Burp Suite. We could just set our proxy to use port 1080, but I always like using Burp Suite so I can tunnel. And I think that's in user options. Yep, we got user options SOX proxy. So if I hit this dev, we get nothing. I'm going to turn Burp Suite on, we get nothing. I'm going to enable use SOX proxy. And then when we refresh, we're going to get a slightly different page once the page actually loads. It's taking its time. Let's see. Maybe Burp Suite is on intercept. Let's see, proxy. Intercept is not on. It is just taking a while to load. Not sure why. Let's see. Can I do /API healthcheck? That works. And we can see the health check here on the dev version is slightly different than the API check on non-dev. So if I just go to RainyCloud API, health check, this is what the health check used to look like. It just said results. So we have a few more options here. So what I'm going to do is send this into Burp Suite. So intercept on, refresh, send it into the repeater, get it just to make sure. And what I'm going to do is change the request method to be a post and hit enter, and we get unauthenticated. So we need to authenticate, and we can probably replay the cookie from a previous request. So let's see. I think we're logged in here. Yeah, we're logged in. So I'm going to refresh this page. Let's see. We don't want the API health check. We have a cookie here. So I can just replay this in here if this is still a valid cookie. And one thing right off the bat, we notice most people probably say this is JWT, but it's actually a unique Flask cookie. Flask is slightly different than JWT. If I look at the decode, let's see. So in a JWT, the very first thing is how it's protected. So this would be like the algorithm HS256 or something, right? But if we look at the very first piece of a Flask cookie, it's actually the data. So we have username is Gary. This piece is just, let's see. Yeah, this piece right here is really small. This is generally in JWT where you'd have the actual data. In Flask, it's something. Invalid if we XXD it. Oh wait, yeah, there's a dash. So it's not even valid base64. I don't know what this piece is. Maybe this is base64 URL encoded actually. So let's see. Copy. This is a rabbit hole I did not intend to go down. So CyberChef. Let's go to Google. May have to turn Burp Suite off so we don't proxy it. CyberChef. And I'm sure there's probably a flag in the base64 binary to do a URL decode, but I don't know it. So let's see. From base64, it's junk. I'm not sure what else to say. You don't really get anything from that piece of the cookie. So, long way of saying, there's another way to identify it's Flask, and this is just the signing piece. So it requires the secret. But when you do a post request to the health check and we're authenticated, we get missing parameter. If we did this with just Rainy Cloud, we also get missing parameter. But I guess we just don't know what parameters there are because we didn't see the request. So when we send this, we know we need a file, maybe type. So let's try file and type. If I do file is equal to etc passwd and type is equal to, let's set it as elf and see what happens. We get result false because etc passwd is not an elf file. If we do type is please subscribe to see what this does. Internal server error, probably because this type doesn't exist. If we go look at the custom type, there is a pattern variable, and it's looking for if the string begins with root, right? So if I do type is equal to custom, and pattern is equal to root, like this, let's see how it returns. We have result is equal to true. If we do pattern is equal to please subscribe, we have result is equal to false. So now we can leak things one character at a time because we can say if this starts with R, then it's true. How about O? And we can leak this one character at a time, right? If it goes to the wrong character, we have result false. What else could we do? The next thing is to probably check if we can match wildcards or match new lines. So let's do /? Jack, because Jack should exist on this box, right? And results nothing. do this, we get result false. If we just do pattern is equal to Jack, result false as well. Jack should exist in this passwd file, but because when it's doing the Python regular expression, it's not saying this period is .all. So somewhere in the syntax there's a re.all that you can do, and that means the dot can match everything, including new lines. So since that parameter is not there, it's not matching a new line. So what I'm going to do is let's go back to root. That's good. I'm going to do a dot stir to make sure this works. So we can use wildcards. And if I do \n, it still says true. And if I look at my passwd file, let's just do a head. So head-2, etc passwd. Daemon is the next thing. So if I do DAE and search this, we have result true. So we can manually put new lines to match it, right? The next line of this file is probably bin. Yep, bin. So we can match bin as well. And again, if we didn't have that line break, daemon, oh, that matched because we have sbin, right? So let's do head 4. Sys should not exist. So if we do sys, result is false. So we need to add that line break, match anything, add another line break, and we should be at the sys line where it's true. So this will allow us to leak an entire file. And if we look, let's go back into this one. It's giving us where the app exists. So this app.py, right? So if I put the file as this instead of passwd, and we want to find out the very first line of the file. Well, most Python files begin with an import, right? So if we do this, we get false. The other thing they could begin with is like user bin Python, right? The shebang Python 3, that's true. And then that's probably going to end the line. So if I do \n, it is true. We can try import, false. So there's probably 2 line breaks there, potentially. And that's true. So at this point, it's going to be really hard for us to guess things because we don't know what libraries it is. This is just very common in Python, so we could like guess it. Let's convert this into a Python script so we can actually brute force it and get the entire file. My first step is to switch over and use VS Code. So I'm just going to launch that. And we're going to make a file. I'm going to call this, I guess, brute.py. I don't know if that's the best name, but we can go here and start a script. Let's see. I don't need to install Docker. The very first thing we want to do is import request because we're going to be making web requests, right? And I'm going to create a function that's essentially going to take the secret, and if it's valid, we'll return true. If invalid, return false. So I'm going to call this get result, and we can say secret here. And then we want to do URL is equal to http dev rainycloud.htb/API/healthcheck. Okay. And we have to pass it a few things. The first thing is our cookie, right? So let's do cookie and then session, and we'll give it the session we have. So let's copy this and paste it in. So that's the cookie. I'm going to do spaces because that's bothering me. The next thing we need to do is give it our payload. So let's do payload is equal to, and copy this, and we have to just convert this over into JSON. So let's do file, grab this, comma, the type is custom, and then pattern. And this will be secret, actually. because this is what we want to actually brute force. So we put that payload. Pattern, I have a comma. Syntax highlighting is so great. We could make this a bit prettier, like if we just put it on lines. I think that looks a bit better. After payload, we need to send this through a proxy. So I'm going to do proxies is equal to, and then we can do probably socks. It said socks 5, so I'm going to give it that. Then 127.0.0.1, 1080, like that. Okay. We send the request, and then this is JSON, so we can do r.json. And I'm just going to say x is equal to get result, and it should begin with a pound. So that's what I'm going to do. So let's print x just to see what it is, run the script, and see what happens. Invalid syntax after type custom. So we need a colon there. Run it. And we have invalid. So it did not return JSON to us. If I print out R, we see it's a 403. And let's see what it says. Access denied, invalid IP. So the 403 is not, it's not converting this into a proxy. Maybe request doesn't natively support socks and we have to install a module or something. So I'm just going to switch it over to Burp Suite. So we can do HTTP 127.0.0.1, 8080. So this now hopefully will work. It looks like it went over into Burp Suite because we have intercept on. And let's see. Result is true. Awesome. So we can say, let's do try, and we'll do return r.json. I'm guessing I can do like result like this, except return false. And then we can return false here. So let's see what this says now. Run this, and we get true. So I'm going to do please subscribe, and hopefully this returns false. Yep. So now we can do a brute force script. So just like before, I'm going to do a while true. And before while true, we can say secret is equal to nothing. So let's do for I in string.printable, and we need to import string. I think if I save it, it may automatically do it now. Let's do import string. So for I in string.printable, and before we did string.printable and got rid of the last 6 characters, I want to say. I'm not going to do that because if we look at string.printable, these are what we trimmed out before. And we definitely want tabs, new lines, returns, things like that. So we're not going to break that. And what we can do is, let's see, while true for I in string.printable, call get result. And then we'll do secret plus I. And we can say if result. We can do that. I'm guessing it's reading my code from the previous thing we did, because that is oddly specific how the AI did that. If you don't know my VS Code, I install GitHub Copilot, so that's why it does all this auto completion thing. So we do that, we break, and I think that's good. Let's just see what this looks like. We run it. It's probably going to take a while. We can verify it's working by going into HTTP history, and we can see it posting 1 character at a time. And this is very long because each request takes a while. We could probably do some magic with async and wildcard characters and do multiple characters at once, but that's probably outside of the scope of this video. So let's see. I guess while that runs, we can change things up a little bit and print how we did before so it looks a bit better. So let's do print. I actually don't know how this is going to work with all the line breaks. So we'll see. So R secret plus I, and like that. And here we will print our secret. So once we get the first character, when we rerun the script, it should look a bit better. It's almost done. And then what we can also do is help this script out by doing user bin Python. Oh, I don't want env. User bin Python 3. I think the user bin env is actually how you're supposed to do it. So we can do \n as well. I don't know if I want to put it in single quotes or not. I guess we'll see how it works. There should be 2 of these. Okay. And I'm still waiting to see. Oh, it got it. We can see 23, and 23 will be that. So I'm going to stop this. We'll run it again and see how it prints. Awesome. Well, not awesome because I guess it's flushing because we have new lines and everything. So doesn't look great, I should say. But oh well. We can see it running. Once it gets the I, we'll know that this is working. And I guess speed up the video so we can see it moves to the next character. And it's going to go all the way to the M. And I'm just going to pretty much let this run. And while I do that, I didn't mention the whole like re.all thing earlier because what we want to find is a line that has secret. And the re.all, if we just did like this, then it would match. And since it matches, we could like skip over a lot of the import statement. But because it didn't, we're kind of just stuck here with this waiting game. So, yeah. So something hilarious happened. Because this is matching wildcards and stuff, it's just getting hung when it came to that. So let's do a quick nasty hack to skip some of these wildcards. I don't know how to do a period. I guess maybe we should escape it. I'm just trying to think maybe if there's a period in this or not. I guess we'll figure that out eventually. So let's see. We have result, secret. So what we want to do is import re for regex. And then what we can say is if re.findAll, and we'll do the regular expression, period, like that, is I, then break. So what this is going to do is skip if we have either of these wildcards. I probably could play with escaping them. Maybe that's the better call. Let's see. What are we looking for? We're looking like this. User, this matches, right? That's true. So that will match. Does that match? False. So let's just escape these instead. So we'll say I is equal to. It's almost like my computer can hear me. Actually, yeah, it was right. If we did single quotes, then we could do a single backtick probably. Maybe not. Let's do it how it said. There we go. So this will probably be fine. We can go up here. We can import. So since we already knew that line was import, I just cheated and added it. And hopefully it gets the space now. So let's run it again. And it's going to try each thing. I really should have did something where it detects if it's completed a line so we get rid of that weird flushing issue. But I think it's working. I'm going to just let this run and see what happens. And that was unexpected. There is a plus, which maybe matches space. I guess we'll find out. I'm thinking plus matches space because it's URL encoded. So maybe we'll find out as soon as it does the next character if it matches whatever it's importing. It's probably like import OS or something. Maybe not, because it passed all the lowercase characters. I could almost guarantee it's going to be a lowercase letter that it imports. I'm going to let it finish, but what we're going to add is plus here to see what happens. And you think I would know all the special characters and not make these mistakes, but we have one more. So question mark. So let's run this again. And hopefully this is the last special character we have. I bet I could do like strings.special. Let's see, a space in there. If I go back here, string dot, so special characters. Let's see. String dot cap digits hex printable. I don't know. I'm going to do the lazy thing and just let this script finish. And hopefully after escaping the question mark, everything is good. Well, this one failed magnificently. Pipe character is also a special character we need to escape. So let's escape that. And then let's see, if I do string.printable, let's just skip all of these. So we only do special characters. So echo-n, wc-c 63. So if I do 63 like that, there we go. So that's how we're going to do it. 63 colon. This should speed things up because we won't go through the alphabet finding all the special characters, right? So it's going to go through these and hopefully it hits space. Where is space? After the squiggly. So we got to here. We know this isn't. So this may be the only special character that can screw us up now, the squiggly. I don't think that's going to. We're at here. So it should be very soon. And I like how the print, how I have it, you can see it actually escaping. If you notice with the question mark, it should be happening fairly shortly. Right now, we can see it with the pipe that it skips right on over that. And come on, space. Yes. So we finally have it. Figures right when I do this testing, we could have just let this script run. Actually, let's skip over. And there we go. So I'm going to let this video resume. It's going to say import RE, and then we're going to pray it does the line break correctly and moves to the next line. And if it does, everything will be good in the world. Well, this is frustrating. It matched the end of the line, but because there's no line break, I don't think it's going to match anything else. So there was one special character we did not account for, which is the $sign. And while we're there, we also should do the caret to match start of line. Send this, and I lost count of what attempt this is, but attempt number X is the charm. It's definitely going to work here. Success! We are now on the second line going through the characters. So it's probably going to take 15 to 20 minutes to get to the line we want, but at least it's working now. So the script is still going off. There's probably a much better way I could do this. Maybe if I just like installed the socks module, it would go a bit faster. But at the end of the day, this is always going to be somewhat slow. I'll probably save improving this script for another video. Maybe we'll convert it to Golang, which allows us to easily compile it and run it on the Docker container itself. I don't think this would just run because, well, maybe it would. Maybe we have Python string and RE. Out of curiosity, let's see how fast this would run if we just got rid of the proxy and ran it on the host. Because there was a Python Docker, right? So let's get rid of proxies. And let's see. Comment that out. Yank. Put. There. So if I just put this on the Docker container itself, I wonder if this goes much faster. You can see how slow this goes, right? So let's stop that. And let's see. That's not it. This is the session. So let's kill chisel. V, we'll call it brute.py again. Set paste. Paste it in. So I've just ran this from here to begin with. Cannot hit dev rainy cloud. Okay. So let's see. What we have to do is probably, let's see. I'm guessing 1801. So I think that 01 is going to be the host whenever you do Docker. And we can see it hits that, redirects to rainycloud.htb, which gets redirected to 127.0.0.1. So I guess DNS is just wacky in this container. And then it gets connection refused. If we did port 22, we can see the wget fails, but it tells us there is SSH identification string. So we know that port's open and it's SSH. I don't think SSH is open on any other container. So that's how we can also validate that that's probably going to be the host, right? So we have to modify the script. So let's see, v brute.py, and we'll put the IP address here. So 172.18.0.1. And since we did that, we have to add something to the header, right? So let's see. Add dev rainy cloud to request header. Does this just magically tell me? Nope. I was hoping Copilot would tell me what to do. I actually don't know how to add header and request. So Python add header request. Google adding a header to the request module. And it's exactly what I thought. So headers is equal to, we can do host dev rainycloud.htb. And maybe that speeds it up. And I wonder if we even have to be. So there's two things we can do here. Part of me is thinking we never tested if we actually have to use the dev thing to hit this function. I know like the health check looks different if we hit it from rainycloud.htb and dev, but I wonder if only like if we gave it all the parameters, if it would still work just fine. So we can do headers is equal to headers. Does this work now? Oh god, that is fast. Look at that. Oh man. So you can see how much the SSH container slowed us down. I'm sure there are some people out there like, just run it on the host. When I'm on Docker, I'm used to like not having Python libraries and things like that. But man, that is fast. So yeah. The other thing I want to test, did we even have to do this? So if I just do rainycloud.htb, this is going to go still slower than the other script because I'm hitting it remotely instead of like this is all on localhost. But it may still work, right? So yeah, it's still going faster. I don't know exactly what it's giving me. We have to get to a line break, which probably won't be too long to see if it actually works, because right now we cheated and it starts at RE. But I don't, yeah, you do have to hit the proxy. So I bet we could set a breakpoint right here. And then if we go into the actual request, let's see, here's the response. We could see exactly what it sends. So if I just do r.text, post only allowed from internal systems. So we do have to use the proxy, but if we did it from the Docker container, it goes a lot faster. Now my screen's kind of freaking out because how I did this paste. But we can, I think, fix that, right? Let's see. Let's only do one. So if I get rid of one of these prints, how does this look? It's still not great, but it is better. I probably have to like put a clear screen first and then paste, but yeah, I think this is working a lot better on the actual container itself. So lesson learned. So now we have it actually hitting secrets.py. So this is the file we want to extract because this is giving us the secret that is used to sign the Flask cookie. So let's get rid of this and go back into our crack script. Let's see. Oh, we called it brute. So brute. And then let's see, what is the file we say? Right here. It's probably going to be secret.py. And we should get rid of one other thing. Let's see. Where is it? This. Where we do secret. And it may be in the secret directory. I should look at this real quick. So from secrets, import secret key. No, I think it's right here. Let's see what happens. It should have got something. Let's see. Where did I screw up? From secrets. I probably did secret, right? There's secret. Yeah, it's secrets. This will hopefully be better. Yep. So we get secret key is equal to a long string. So this is going to be what is used to sign the Flask cookies, right? So let's go to a new window, and we're going to use the application Flask unsign, which is a Python thing that I installed through pip, I believe. So like pip3 install Flask unsign if you don't have it. We specify -s for sign, then we give it the secret, and then we give it the cookie we want to sign. And that will be the Flask session. So let's go get one of our sessions. So if we just copy this first piece, I'm actually going to get from Burp Suite because it is bigger. So we can copy this and then echo-n paste base64-d. And if we wanted to, I think that would be 2 padding. Yep, there we go. So the base64 you can just ignore. It's just padding that's missing. But we have username Gary. And we want to change that to username is equal to Jack. Because if we go back to the main page and look at the containers, Jack is another user. And we want to gain access to this secret container, right? So let's go here. And Run this. So now we have signed this cookie. And if I edit my session and we go to my containers, I should be the Jack user. I am because we don't see my other containers. And I'm running in this container. So if I execute command and ran like ID, it will be 1000. If we did that as Gary, it was Leet. Background is also 1000 as well. It's a bit of a pain to get that output. So that is the main difference between, that is the only difference between Jack and Gary is execute command is also UID 1000. If we wanted to, we can look at the actual code. So let's see, SSH is here. I can vim on app.py. And if we look at the code that spawns this, it is, what function is it? /containers. And we go down to where it has that leet. We can see there's two actions. We can do exec detach or exec, and these are different. We have a timeout 5 seconds. So if it is just exec, this shell's only going to last 5 seconds long. It's going to do the action command, set privileged, and user ID is 1000. However, or user is equal to 1000 if the session name is equal to Jack, else it's equal to leet. So that's why when we were Gary and we did the execute command, we got UID of leet and not 1000 because it was executing as that user. However, this logic is missing from the detach function. And the detach just doesn't really have the timeout, but it also doesn't have the logic of if the user isn't Jack, then set the UID to leet. So that's why Gary can be UID 1000, which does allow him to do the same thing that Jack did, is go into the host and get that process through current working directory. And if you're still confused, I suppose we can take a few seconds and go back to the container. I am in the container. So if we did ps-ef grep for sleep we can see this is the process ID that's running on the host. This is my user ID 1000. So if I was UID 1337, I can't access the proc 1194 directory. Let's see, does it show it? LA grep 1194. Let's see, we can access, we have read, anyone has access to this. If we do lsla here, let's see what CWD says. Home Jack. So I'm guessing Jack is UID 1000 on the box. Because it's a symlink, we have all these weird permissions. So if I went out of here, lsla on /home, it's going to take this permission set, and Jack is going to be UID 1000, and the earner and group can read it, the earner can read write, and then everyone, which UID 1337 would fall into, can't do anything on this directory. And if we just grep Jack on etc passwd, we can confirm he is indeed an UID 1000. So hopefully that all makes sense. Take care, guys, and I'll see you all next time.